Good day everyone, so I will discuss to you the demand paging. Demand paging mechanism is very much similar to the paging system, with swapping where process stored in secondary memory and pages are loaded only in demand, not in advance. So your process will be stored in your test and those pages are loaded on demand. So you see on demand, say it will be this request of your CPU to load the process. So in a context switch, of course, the OS never copy the old program's pages from the desk or any of the new program's pages into the main memory. Instead, it will start executing the new program after loading the first page and fetches the program pages which are referenced. So if ever there are reference pages which is already in your main memory, it will not copy the old program pages from your secondary. So instead, it will start a new program and pitches those programs that are referenced. So kung na siya available pages in the main memory, it will not swap or it will not copy those old pages from the secondary memory. So during the program execution, if the program references a page that may not be available in main memory because it was already swapped into your secondary memory, then the processor considered it as an invalid memory or a page fault. So again, kung if there are program references a page which is not available in your main memory, wala siya sa main memory, so wala siya sa main memory, then it is known as the invalid memory references and it will be called as page fault. So if ever this will happen, so it will transfer the control back to your program to the OS. So it will transfer again your program to OS and it will demand to store the page back in the memory. So mo-demand siya sa imuhang page back into your secondary memory and then into the memory, and then iyan na store sa imuhang main memory. So this is an example of your demand paging. Again, you have your main memory and your secondary memory. So you have two processes that was swapped in from secondary memory to your main memory, and then your process 2 is swapped out to your secondary memory. So in this process, if your CPU requests these letters that are available in your secondary memory and then swapped in to your main memory, so since the request is already available, was in the memory, or since your request is not in the memory, so it is known as the page fault. So it will be swapped into the memory. Since your process is already available, and if ever there are other processes that want to swap in your process 2, but still there are available processes, so you can swap out these processes that are not being used or not being requested with your CPU. You can swap out your process to your secondary memory for swap out or replace this process for the other process for you to have a reference page or a space for the other process request of your CPU. So there are different replacement algorithm, that page replacement algorithm in your paging. So a page replacement algorithm are the techniques using which an OS decide which memory pages to swap out or to write to disk when a page memory needs to be allocated. So as what I have said earlier, if your memory needs to allocate, or your CPU requests a process to be allocated in your main memory, so there will be a page replacement using page swapping. So the demand paging method, so whatever the process that was requested by the CPU, so it should be allocated in your main memory. But since there are processes that are placed in your main memory, so it will be transferred or swapped out into your secondary memory for the main memory to have an available space for swapping or for replacement. So paging happens whenever a page fault occurs and a free page cannot be used for allocation purposes, accounting to the reason the pages are not available or the number of free pages are lower than the required pages. So again, there will be a page fault or invalid memory if there is a free page that cannot be used for allocation purposes, accounting to the reason that the pages are not available or the number of free pages is lower than the required pages. So that will be called an invalid memory. So in the page that was selected for replacement and was page out is referred again, so it is to read in from the text, and this require an input and output completion. So this process determines the quality of the page replacement algorithm. So the lesser the time waiting for page ins, the better is the algorithm. So a page replacement algorithm looks at the limited information about accessing the pages provided by the hardware. It tries to select which pages should be replaced to minimize the total of page misses, while balancing it with the cost of primary storage and processor time of the algorithm itself. So when you say page misses, so you have to minimize the invalid reference. So there are different types of your reference string are the string of the memory references. So it will be generated artificially or by tracing a given system and recording the address of each memory references. So always note that for a given page's size, we need to consider only the page number, not the entire address. So in swapping, you have to consider only the page number. So if we have a reference to a page P, then any immediately following reference to page P will never cause a page fault. So page P will be in memory after the first reference, then the immediate following references will not be full. So there are different types of page replacement method. So these are very important page replacement methods for you to consider the swapping of your pages to your main memory. So you have your FIFO, or the first in, first out, the optimal algorithm, and the LRU page replacement, or the least replacement unit. So we will start with FIFO or FIFO page replacement. So FIFO means first in, first out, is a simple implementation method. So in this method, memory selects the page for replacement that has been in the virtual address of your memory for the longest time. So it will replace for those addresses that are residing in the longest time. So again, for the first in, first out, so the replacement will be applicable for those addresses of the memory that has a longest time. So ang dugay sa memory mao'y replacean, mao'y ilisdan. So the features of this FIFO page replacement. So whenever a new page loaded, the page recently comes in the memory is removed. So if whatever page removed, and then there will be new page loaded, so it will comes to the memory that is removed. So it is easy to decide which page requires to be removed, as its identification number is always the FIFO stack. So sayon ra siya ang decide what page is to remove, because we're using the FIFO stack, which is to replace the longest time, replace the page that are available in the memory for longest time. So when you say longest time, so the earliest time for the memory. So the oldest page in the main memory is the one that should be selected for replacement first. So saktan ha. So for FIFO, so whatever the process that was inputted first, so it should be the one that will be out first. Sa kinang una og gi-input sa memory, mo say mag-una og out sa memory. The oldest and the longest time. This is an example of your FIFO algorithm. So again, don't forget, it will be the oldest page in the main memory will be selected for replacement. So this is easy to implement. You just have to keep a list and replace the pages from the tail. and then add a new pages at the head. So mag-replace ta sa ubos, then mag-add ta sa, so this will be your reference string that are requested by the CPU. So misses is your page fault. Kaning mga X will serve as your page fault. So we will check why is it your 0 is a page fault. Diba? May mga page fault when there is no available memory that has been requested by the CPU. So with this one, so ang kanisiya, you have your 0, 2, 1, 6. Then next process is your 4. So naka page fault na siya. Next process is your 4. So your 4 will be swapped to the available pages in your main memory. So it swaps siya in your main memory. The question is where to swap the 4. So again, it is the first in first out manda. So the first who enter in your main memory is 0. So you have to replace your 0 kanisiya with 4. That's why your new process in your main memory is 4216 na kanisya, 4216. So again, the one that was being replaced was 0. So your next process is 0 kanisya. So where should we replace the 0? So dili kanisiya, kani 2. You have to replace 2. So that's why your process will be 4016 na in your main memory. The next is 1. You have to replace 1. Since 1 is available in your main memory, so it will not be replaced. So you have to copy na lang. So that's why wala siya naka-page fault. As you can see, wala siya X. Diba? For your process 1, wala siya naka X, diba? Kabantay ka, wala ka X. That's why wala siya naka X kay available man ihang process sa main memory, so it will not be replaced. Next process, we'll go to the next process. The next process will be your 0. So since 0 is still available, so wala sa siya i-replace, so wala siya naka-page fault. The next process is 3. May siya 3. So is there any available 3 in the main memory? Wala. So it will be replaced. The question is, asaan na siya ang the oldest page in your main memory? So diba, sa una ang oldest page yung tayo 0. Ano siya? But it was being replaced by 4. So dili na siya mahugog old. Next oldest page is 2. Nag-replacean man ang 2, 0. So dili na siya old. So the one that are not replaced is 1. Gani siya. So oldest ni siya. That's why it will be replaced with 3. So since 3 is not available in your page, so mahog siya page fault. Naka-X siya. Next, you have this process na in your main memory. So you have to replace until there your CPU requests a 1. CPU request 1. Yung manamda sa 3. So 1 na ta sa 1. So your CPU request 1. So as you can see, in this memory, there is no 1. So the question is where to replace 1. Since kanisiya, katong 1 is already replaced, your 6 is not replaced pa. So mahog siya old na siya. So that's why your 1 will be replaced to your 6. So this will serve as your new main memory. So next for 1 is 2. Is 2 available in the main memory? No. So it will serve as the page fault. Kani siya 2. Your 2 is not available in your main memory. So nahog siya page fault. So that's why naka-X siya. And then it will replace to the oldest na sad, which is your 4. As you can see, ang 4 kaupat na siya. So meaning siya ang pinaka-old. So your 2 will be replaced to your 4. The next request is your process page 1. But since your page 1 is available, that's why wala siya page default. So your last output will be this one. Kani. So the pages that are available in your main memory is 2031. So this is the way of replacing your pages in your main memory using FIFO replacement algorithm. But if you're going to get the fault rate for your FIFO algorithm, you have to count the page fault that is available in your FIFO, and siya kaning all x will be counted, and it will be divided for all the total reference string. So the result will be your page fault rate. So again, to get the fault rate, it was the total page fault divided by the total reference string. So mga na siya, nahulog na siya 0.75. Let's set an example for you to understand ganun na inato ang FIFO algorithm. If this is your memory, so diba nahulog siya, pila to? 4. So this is your main memory. So again, we'll be using FIFO. So when you say FIFO, it will be the first in, first out. So kung kinsa tong pinaka-longest sa memory will be out. Mao siya'y mawala sa main memory. So let's trace why is it your 0 is known as your page fault. Kani siyang misses is page fault ni siya. Again, there will be page fault if your request or the CPU request is not available or it has been already swapped into your secondary memory. This will serve as your main memory, where you will be storing your request, the request of your CPU, katong request pages. So we will start with 0. Kani siya 0. So when the CPU requests 0, it will be checked to your main memory if your 0 is available. So since sa inyong main memory is wala pa siya pages na butang, so this will serve as your default page fault. Kaya wala man siya sa main memory, di ba? Wala siya sa main memory, invalid ang mga reference, meaning there is a page fault. So now, page fault. So what will happen? Or request siya sa OS to load your pages. So kani 0, ma-load na ni siya sa imuhang frame 1. So mahog man ni siya frame 1, kani dali frame 1. So again, naka-page fault ka, that's why naka-X ang mga 0. Next is you have to load the 2. Since your 2 is not available in your main memory, kaya ang na-available man is 0 and 2, i-load na mo si 2. I-load na mo si 2. So your 2 is also a page fault. X and siya. The next process is your 1. Again, your 1 is not available in your main memory, so you have to load your 1. So X lang yapon siya, page fault lang yapon siya. Kaya wala man siya sa main memory. And the next process is 6. Again, your 6 is not available to your main memory. Manang nahog siya to 6. So X lang yapon siya, page fault. And the next process for 6 is 4. The question is where to put your 4. So in the rule for FIFO, the oldest page that are available in your main memory will be replaced by the new request. So you have your request 4. Request nimo is 4. Ni siya. Yan siya 4. So again, the oldest that are, or the longest time that was been in your main memory will be replaced. So, as you can see, ang 0, kaupat na siya. So, mahong siya pinaka-longest na time. So, you will replace 0 with 4. Ano siya na 4, 2, 1, 6. So, again, page fault ng gamon siya kay 4 is not available in your main memory man. Next is 0. As you can see, in the main memory, there is no 0. So, replace that. Question is, as I shall replace, so it should be 2. Okay? It will be replaced with 0, 1, 6. Page fault na yapon siya, kaya wala man siya. On the next part is your 1. Yeah. Since your 1 is available in your main memory, so no need to replace. Kaya naaman siya. Sumahog na siya dili page fault. Tumaon lang, you have to copy na lang for 0, 1, 6. So, dili siya mahog o page fault. So, ang tawagan na niya is page hit. So, naa siya available siya. And 1. Next is your 0. Since your 0 is also available in your main memory, so dili ra sad siya i-replace. Standby lang 0. So, hit lang yapon siya, page hit siya. So, another example is 3. So, as you can see, 3 is not available in your main memory. So, mag-replace tag 3. Ang pangutana asa si 3 i-replace. So, we will replace 3 sa 1. Kaya taas iyang pag-stay sa main memory ang 1. So, this will serve as your 4, 0, 3, and 6. So, again, your 3 is not available in main memory. So, mahog siyang page fault. Next for 3 is 1. Since 1 is not available, so you have to replace. Ang pangutana asa i-replace si 1. So, as you can see, mas longest time ang 6. So, we will replace 1 sa portion nga sa 6. So, this will serve as your 4, 0, 3, 1. So, again, your 1 is naka-page fault siya. Next for 1 is 2. Page fault ni siya. Next for 1 is 2. Is there any 2? Wala. So, ang pangutana asa siya replace sa 4. Kaya taas ang 4. So, this will serve as your 2, 0, 3, 1. Page fault siya. Next to replace is 1. So, the last part is 1. So, for your 1, naa siya available siya. So, mahog siya, hit lang. Naa man available. So, you have to copy na lang the main memory. And since there are no requests, so stop na ta. Since there are no page requests, so stop na ta. So, the available pages in your main memory na is your 2031. So, to get the page fault ratio, you have to get the total page fault divided by your total reference string. So, kani ang total page fault niya is 9 divided by total reference string is 12. So, the result will be your page fault ratio. So, sayo na ang FIFO, no? Next for FIFO is your optimal algorithm. So, for your optimal page replacement method, it selects the page for the replacement for which the time to the next reference is the longest. So, again, dili siya magmatter sa longest nga naa sa main memory, but magmatter siya sa longest next reference. So, dili ta magmatter atong nana sa main memory. Magmatter ta sa sunod pa yun, ang pinaka-longest nga reference. So, pangita na ka ani nga process nga whatever the next process nga ang pinaka-longest nga reference that is available in your main memory. So, for the features for optimal is the fewest the number of the page fault. This algorithm is difficult to implement. So, kung gamay ra ang numbers imong page fault, mas lisod siya i-implement. Next is an optimal page replacement algorithm method has the lowest page fault rate of all algorithm. So, this algorithm exists and which should be called mean or opt. So, to replace the page, you have to use the longer period of time. So, it only uses the time for the page needs to be used. So, the next pages na siya nga gamiton for optimal algorithm. So, we will have your example. So, this is an example of optimal replacement algorithm that has the lowest page fault rate of all algorithm. So, the replacement exists. If exists, they can be called as op or min. So, replace the page that will not be used for the longest period of time. or use the time when the page is to be used. So with this one, again, you have your 0, 2, 1, 6. Same process ganito. Since wala pa man siya sa main memory, naka-page default siya. Next is 4. Since you're 4, so where to replace 4? So you have to check which of the available process that is the longest to be referenced in the next future process. So diba, for your main memory, you have 0. So 0 will be replaced next. So di siya pwede. Next is 2. Your 2 will be replaced. Mas taas siya, the 0. So we'll check sa 1. Ang 1 di siya pwede. So di siya pwede kasi sunod lang siya sa 0, diba? Yeah, for your 2, magsunod siya sa 0. Next is your 6. So since your 6 is not available, so pwede siyang i-replace. So we will have to replace your 6 for 4. So your available main memory will be this one. Can you see? So next to replace is page fault ang 4. Okay, wala. Next to replace is 0. Since your 0 is available in your main memory, so copy ra na siya. No need to replace. So that will serve as your page hit. Hit siya, kinaaman siya, available ang 0. The next number to be referenced is your 1. Available sa lang 1, so copy ra sad. Next is 0. Available sa lang 0, so copy ra sad. The next part is 3. The question is, asa siya i-replace, diba? For the longest time to be referenced man. Itong i-reference. So if we will check, next for 3 is 1. So that is available today. Next for 2. So 2 na and 1 na asad. So since 4 is the newest page na replacement, so you have to replace 0. So that's why your 3 was been placed to 0, and then you have your 2, 1, 4. Since next for 3 is 1, which is available, and 2 which is available, and 1 which is available, so your main memory processes are 3, 2, 1, 4. If you're going to check the fault rate, you have to divide the page fault 6, and it's just 6x divided by the total reference 3. So mauna siya mo false rate. So that is for optimal algorithm. We will check using this one. One, 2, 3, 4. So this will serve as your frames. So again, this is an optimal algorithm. We will check for the longest reference, next reference. Dili katong reference na sa main memory. This will be the next reference number pages. I will start with 0. Your 0 is not available in your main memory. So mahog siyang page fault. Next for 0 is 2. 0, 2, which is not available in your main memory. So mahog lang yapon siyang page fault. 4 frames man din siya. Kalimot ko. So page fault ni siya, kanisad fault ni siya. And next is 1. Since your 1 is not available in your main memory, page fault sa siya. Next for 1 is 6. Wala sa siya. Page fault sa siya. Next is 4. So again, for the optimal algorithm, it is the available reference, the longest next reference pages for the algorithm. So again, katong next reference dili katong available sa main memory. Sa una man sa FIFO is kung kinsa tong longest time available in the main memory. Ani siyang sa optimal, so it should be the longest time, which is to be next reference. So ang sa tong sunod nga i-reference sa imong main memory. So again, you have to reference your 4. So whatever available in your main memory should be checked for the next reference. Then, example, diba, you have your 4. 4. So next for 4, next reference for 4 is 0. So that's why kani siya 0. So next man siya sa 4, so dili siya matawag og longest nga in next reference. So for 2, naasad sa 2. Pero kung tanaw nimo ang 2, layo-layo siya. But you have to check the another available nga pages sa mga main memory. So standby na ang 2. Next is your 1. So your 1 will be served as nagsunod siya sa 0. So duol-duol sa siya. So dili siya pwede. Next is 6. So since 6 is not available in your reference string, so mahog siya ang i-replace. So kung kuan pa siya, mas layo siya sa 2. Kinaaman available man ang 2. So you will change your 4 sa 6. 0, 2, 1, 4. So again, this will serve as your page fault. Okay, wala siya sa main memory. Next for your 4 is 0. Since 0 is available in your main memory, so copy lang ta. 0, 2, 1, 4. So it will be hit. Hit siya. Why? Available man siya sa mga main memory. Next for 0 is 1. Nasa siya. So copy sa ta. Hit sa siya. Next is 0. Halang yapon. Copy na yapon. Next for 0 is 3. So you have to check kung saan pwede i-change. So, ang next reference for 3 is 1, 2, 1. Na siya 1, 2, 1. So ang wala, si 0 o si 4. But since nag-una si 0, you have to check the longest na sa imuhang main memory. Stay sa main memory. Diba ang 0, longest na siya. So you have to replace 0. Tapo, mayroon siyang 3, 2, 1, 4. So again, this will be page fault. The next for 3 is 1. So mahawag na siya. 1, 3, 2, 1, 4. Hit ni siya. Diba? Mahawag ni siya hit. Okay, naap man siya. Available man siya sa memory mo. Mahawag siya hit. 3, 2, 1, 4. Hit. And next is your hit. Next is your 2. Since 2 is available, 3, 2, 1, 4 lang yan po ni siya. Hit lang yan siya. Next is 1. Since 1 is available, you have 3, 2, 1, 4. So the remaining memory in your is 3, 2, 1, 4. So to get the page fault, you have to divide the total page fault, which is 6. Mga siya 1, 2, 3, 4, 5, 6. Divided by the total number of reference 3. So that is for optimal. Again, for optimal, we will focus on the next reference pages, not on the available in the memory, the longest time in the memory. So for optimal, it should be the longest next reference pages. Next for optimal is your LRU page replacement, or the last recently used page. So this method helps OS to find page usage over a short period of time. So this algorithm should be implemented by associating a counter with an event page. So how does it work? The page which has not been used for the longest time in the main memory is the one that will be selected for replacement. So it is easy to implement. You have to keep a list, replace pages by looking back into time. So this is an example of your features of your LRU page replacement. Your LRU replacement method has the highest count. This count is also called as aging register. So this specifies their age and how much their associated pages should also be referenced. So the page which hasn't been used for the longest time in the main memory is the one that should be selected for replacement. So it also keeps a list and replaces pages by looking back into the time. So since your FIFO is the longest in your main memory, so your least recently used are those pages that has not been used for a longest of time in your main memory. So it is easy to implement. Again, you have to keep a list and replace pages by looking. So again, your least recently used algorithm used the longest time in main memory is what which is been selected for replacement. So it's just the same with FIFO. The only difference is we have to look back the time that was being used or the least recently used. So in this example, you have your 021640103121 for your reference string. So again, you know already how to get the page fault and the hit. So we will start with 02164, which will serve as your page fault. Then since the frames are already allocated with pages, can you see? So you have to replace the 4. So since we're looking for the, can you mention 4? Since we're looking for the least replacement used man, the least recently used. So you have to check the pages that has been being used. You have your 0216. If you're going to check, your 6 will be the most recently used. So mauna ang bago nimong gigamit. So that will not serve as your least recently used. So kung may list recently used, ang atong pinakaawit nga gigamit. So that's why your 0 is your LRU. So you will replace your 0 with 4. Mauna ni siya. And next for 4 is 0. So since 0, and you will check, ang 4 is your most used. And the next is your least used is your 2. 2 na siya. Di man sa siya pwede ang 0 kay 0 man may replace. So it should be 2. So that's why you will replace 2. Now, wala na sa available and zeros. 2. So this will serve as your new memory. Of your 4016. Next for 0 is 1. Since your 1 is available, so it will serve as a hit lang. So next is 0. Since 0 is also available in the main memory, hits at siya. The next to be replaced is on the next page that was been demanded by the CPU is 3. So the CPU demands 3 to replace in the main memory. The question is, unsa iyahang i-replace? So if you're going to check your 3, your 4, na siyang 4. Next is your 0, which is the next. So recently used siyang 0. Next is your 1. 1 is also recently used. Then the last recently used is 6. So that's why you're going to replace 6 with 3. So mauna ni siya. Next for 3 is 1, which is 1 is available in main memory, so no need to replace. Hit ra siya. And the next to replace is 2. So we will check your 2. So since in your main memory you have 4, can you see 4, 4, your 0. So since 4 is being used man, so you have 4, 0, most recently, then 3, so you will replace your 4 kasi yaman ang less recently used ang 4. So again. So you have to replace 2. Yung 2. Replacing mo ang 2. Since in your memory you have 4. 0, 1, and 3. So the less recently used is your 4. So that's why your 2 will be replaced at 4. So this will serve as your memory. Okay, next for 2 is 1, which is 1 is available for your main memory. So we will check again. So again, your reference string is 0216 216 401 03121 03121. So again, you have 4 frames, 1, 2, 3, and 4. So we will be using the least recently used algorithm. So again, you have your 0, which serves as your fault, page fault, your 2, your 1, and your 6. So they are page fault. And next is where to replace 4. Ganin siya, 4. Where to replace 4. Since you will be using list recently used, so you will check for those pages that are available in memory that are not are list recently used. Diba, you have your 0, 2, 1, and 6. Now, if you're going to check your most recently used or katong bago pa nimong gigamit is 6. So, dili siya pwede for list recently used. So, it should be 0. Okay, siya man ang pinaka katong wala na siya gigamit pa list. So, this will serve as your most recently used. Then, this will serve as your least recently used. So, 0, you have to replace 0 with 4. So, ay na kay 4, 2, 1, 6. And next, your 0. So, we will check kung saan ang least recently used. So, you will have to replace 0. So, since 0, you have your 4. Check ha kung naansang na 4, 2, 1, and 6. So, the least recently used is 2. 2. So, you have to replace 2 with 0. Next for 0 is 1. Since 1 is available, copy na siya. So, this will serve as heap. So, next is 0. When 0 is available, copy na siya. So, this will serve as your heat. Next for 0 is 3. So, you have to check kung unsa ang list used in the main memory. So, you have your 4, 0, 1, and 6. So, the last used is 6. So, you have to replace 6 with 3. So, mayroon siyang 4, 0, 1, 3. And next is you have to place 1. Since 1 is available, mahuplay siya 4, 0, 1, 3. And next, 2. Since 2 is not available, you have to check saan na ang left recently used. So, you have your 2 man to no, 2. Kani 2. You have your 4, 0, 1, and 3. So, the least recently used is 4. You have to change 4 by 2. Copy na ang 1. Serve as your page fault. Next for 2 is 1. Since 1 is available, so your answer should be 2, 0, 1, 3, which is page hit. So, this will be the remaining pages in your main memory. So, that is your LRU. So, thank you.